And welcome, Mindsetters, to this session of Learn Extra Live. Grade 10s, I hope you're ready for this lesson on science. Today I've got Tracy in with me.
I'm back. I've missed them.
I know, we've missed you too.
I know. I like them more. Sorry.
So, tell us what's happening today.
Well, today we're going to carry on. Phil's been doing a little bit on vectors and scalars, and we've done displacement and position and stuff. So today we get on to the fun part of doing speed, not the drug. Speed and velocity and acceleration. So we're going to look at average speed, average velocity, and acceleration, and do the thing they really hate the most and do some calculations. But it's cool.
But we'll have fun either way.
I love this section. This is actually a really nice section. Once you've got it, and if you follow all the rules,
then you're sorted.
Sorted.
All right. So while Tracy makes her way to the board, I'm going to tell these Mindsetters, make sure, as I always say, you get on the page and chat to me. Let me know if you guys are having any problems, if you're having any issues, if you're lost anywhere, if you need help. Let me know. All you have to do is just post it on the Facebook page. And guys, Mindsetters, I cannot stress enough, I have this awesome calculator and this labeler to give away, so make sure you get on the page and chat to us. On that note, I just want to send a quick shout out to Liberty. Thank you for sponsoring. So, this is where I then hand over to Tracy. Tracy, take it away.
Oh, thank you, Ty. And I'm really hoping my grade 10s are actually watching because we've just started this section. So, they better be watching or I'm going to smack them when I get to school tomorrow. No, I won't really, just so you know. Anyway, so we're looking at motion in one dimension. In some of your books, it'll say motion in one direction. All that means, grade 10s, is it's really nice in that at this level, we really just look at objects that are either moving just horizontally or objects that are moving vertically, okay? Now, to describe the motion of an object, you've spent a couple of sessions now, and Phil was with you, looking at things like position and displacement, okay? Where we need to look at, are we describing an object's distance? Remember, distance is a scalar. So are we describing whether the object just went 20 meters or 17 meters east, however. So we're either just going to describe a distance which has no direction, or we need to consider the object's displacement, okay, where we're looking at the fact that an object goes a specific distance in a specific direction, okay, so those are your vectors. Then we need to consider speed and velocity. Now, you've spent the last couple of weeks looking particularly at position and displacement. Okay, now what we're going to look at today is we're going to look at speed and velocity and acceleration. In fact, we're going to do this over the next couple of weeks. What we're going to discuss is essentially what the difference is between speed and velocity. I'm hoping most of you know speed is a scalar, velocity is a vector, and then we're going to look at acceleration. Acceleration is most definitely a vector. It has a direction. We sometimes talk about deceleration. Deceleration isn't a great word, grade 10s. I need you to try and get it out of your vocabulary. I know some of your teachers might still be using it. It's fine. It's just not technically 100% correct because it actually refers to negative acceleration. And when we talk about something decelerating, we're talking about it slowing down, which is what negative acceleration does. Okay? But what we need to get is today, specifically, we're going to look at speed, velocity, and acceleration, because those are really important concepts. And we're going to look at the difference between speed and velocity and how we distinguish between them, and then how acceleration relates to them. So, first thing, what is speed? Okay? Speed, well, average speed is the distance traveled divided by the time taken for a journey. Distance being a scalar. Capital D, some of your teachers might be insisting that you use an X. That's fine. There's nothing wrong with that. Okay. Changing distance, changing time. So if I write this equation as an equation without the words, okay, I want you to see something. Is here, I'm going to say average speed is changing distance over changing time. You need to take note of certain things, please, grade 10s. Number one, that triangle is pronounced delta, and it means change in. Okay? So that's what it means. What that means is we want to look at how does the distance change? Did the distance change by 10 meters, 20 meters, 400 kilometers? What happened to the distance? So how did it change? That means if delta D is distance, okay, so let's write it over here. So delta D is my changing distance. distance is a length, which means its SI unit is meters. Okay, its SI unit is meters. Delta T is change in time. And often they'll just tell you things like, the car went 300 meters in 10 seconds. That's the same as change in distance over change in time. Okay? Time is measured in seconds. Please, grade 10s, this is really important. In English, you are allowed to abbreviate the word seconds to SEC, to sec. Okay, as long as you put a full stop at the end. You may not do that in science. This is not accepted. You will get naught for that unit. Okay, so be careful, grade 10s. It's really, really important that you get that it's S and it's lowercase s. What does that mean in terms of finding the units for speed? Now, I'm doing average speed. Okay, I'm not putting a line over the top. I'll show you how we do velocity in a second. So this is average speed, and I'm being very specific today, grade 10s, because next week we're going to do instantaneous, and we're going to look at some ticket timers and do all sorts of wonderful things. Now, average speed is meters per second, distance divided by time. Okay, meters per second. Very, very important. Okay, I'm using average. If some of you teachers might be going, well, you don't need to put the AV, that's fine. You're not going to often use speed after grade 10 because it's not a very, it doesn't tell us very much, okay? And we know the Olympics have just been and the Paralympics are about to start. When we look at athletics in particular, they often talk about the speed of an athlete. And in fact, we're going to come across the fact that someone like a 800-meter athlete or a 400-meter athlete who starts right at the finish line actually has no velocity by the time they're finished because they finish and start in the same place. But we won't tell any of our athletes that because especially our schools just run the inter-high, and we don't want to tell 400-meter athletes that. They'll get a little upset, particularly because of all the energy they use. But if you start and stop at the same place, you have no displacement. We'll come back to that. Okay, so average speed, meters per second. How is that different from velocity? Well, this should say average velocity. It's a good thing I checked this. Sorry. Average velocity is the change in position of a body, delta x, divided by time delta t taken for the journey. Very, very important here, grade 10s. Average velocity, it's got a line over the top, okay? Average velocity, very, very, very important. The line tells me we're doing vectors now, okay? Is change in displacement over change in time. You may not use a D here because now the displacement means the direction is really important. It's not just the case of whether the object went 100 meters or 3 kilometers. It's whether it went 100 meters north or whether it went 10 meters south, okay? And remember last week when you were with Phil, you looked at the fact that you could get a resultant displacement or a resultant force. So when we look at displacement, we actually can look at, we ignore the path taken. So we ignore the winding and the bends and all the rest of it, and we simply look at the shortest distance from beginning to end, and we draw a straight line. That's the displacement, okay? That's really important for us to get here. But what's important here is displacement. So that change is my change in displacement. And that is measured in meters. That's time. Time is measured in seconds. And this is velocity, average velocity. Same unit as speed, meters per second. Please be careful here, grade 10s. When it comes to describing the motion of cars and aeroplanes and those sort of things and bikes and motorbikes and all sorts of things, we often want to use kilometers per hour because kilometers per hour make more sense. I mean, if we had to say, well, you know, the speed on the highway is 30 meters per second, that would just be a little silly, Okay, so we go 120 kilometers per hour because it's just a more accepted way of writing and measuring velocity. Also, meters and seconds are our SI units, our base units. Kilometers come from meters, hours come from seconds. So this is our bases. Okay. What's important here? Number one, speed is a scalar. Speed cannot be negative because you don't have direction. Okay, you can only go speed. You're either getting faster or slow, but it's positive speed. Velocity, however, can be negative because velocity has direction. And whether you get a positive or negative answer at the end of a sum depends on your sign convention. So it depends on the direction you have chosen as positive. Be careful here. In a question, it is possible for your examiner or your teacher to say to you, you must, to the left is positive, or up is positive, or to north is positive. They are well within their rights to do that, which then means you have to work within that parameter. You cannot change that, grade 10s, okay? But if they don't give you a sign convention and they just give you a question, you decide on the sign convention and stick with it. Don't change it halfway through because you're not allowed to. It's the same motion, okay? So if you choose that going to the left is positive, stick with going to the left is positive. If you end up with a negative answer, that just means that whatever you're working out, whether it be displacement or velocity, just means that it's now going to the right. Okay, very, very important. The negative gives you direction. So velocity can have a negative value to it, but speed cannot. Okay? It is possible, now I'm going to freak you out a little bit, to have constant, and I want you to think about this, a situation where you have constant speed, but not constant velocity. And I'm sure some of you are going, nah, you're lying to us, Tracy. But I'm not, because constant velocity and speed, are measured in meters per second, okay? Now, if you consider a cyclist going round in a circle on a track, indoor cyclist, they go round in a circle, nice perfect circle, they go round and round and round, which gets you a little dizzy, but anyway, as they go round the circle, their speed can remain constant. Why? Because I don't care about the direction. I don't care, and it'll probably be easier if I draw it over here for you. Okay. It's a good thing I put in extra pages, hey? Okay, sorry, I just want to quickly give me a blank page. So I'm just going to take these off quickly, or not. Unlock and take away. There we go. You've seen what we're going to do later, but that's okay. All right, so circular track. Okay, our wonderful cyclist goes for a ride. Silly person. Okay, and they go round and round and round and round and round. Constant speed all the way around. Okay, but if we had to draw in a line to show the direction, so he's going in that direction, then he's going that direction. So if we had to draw little tangents, can you see that the direction keeps changing as he goes round? Now, because his direction is changing, his velocity is changing. Not in magnitude, but in direction. That means the velocity is not constant. Okay? Very important for you to get this. Means his velocity isn't constant. Plus, if our cyclist starts and stops at the same place, he can have an average speed because he has, and I've moved some arrows, because he has moved a certain distance, irrespective of displacement. But if he starts and stops in the same place, his displacement is 0 because there's no distance between where he started and he stopped. If his displacement is 0, his average velocity is 0. And I'm talking average, grade 10s, not instantaneous. I'm not saying what was his velocity at that point, okay, or at that point. I'm saying what was his average by the time he got to the end. Okay. And I actually have this in table form for you, so we can do a bit of a comparison, okay? Speed depends on the path. What do I mean by that? Speed really is about the whole path that I take, okay? Going up and down and around, and whether I double back on myself and all of that sort of thing. So if you're training for, say, the comrades, okay, speed, when you look at your speed and you run around the block 700 times, which could be a little boring, I suppose, but speed goes, well, okay, I ran around the block and I count all those distances together. Velocity is independent of the path you take, because velocity only depends on starting point, end point, okay? Speed is always, always, always positive, never negative. Velocity can be positive or negative. We spoke about that. Depends on direction. Speed is a scalar. Velocity is a vector. Speed does not depend on direction. Very, very, very important that you get this. Speed does not depend on direction. We do not care which direction you went in. We don't care how many times you double back, how many times you went west, how many times, because all we do is we take all the little pieces, add them together, get your total distance. Velocity absolutely depends on direction. Whatever direction your displacement is in, most of the time that's the direction your velocity will be in. Why am I only saying most of the time? Because you can have a situation where, actually no, it is the same direction as your, never mind, ignore what I just said, I'm thinking of acceleration. So the point is, even if you are moving forward but slowing down, your velocity is still in the same direction as your displacement. Your acceleration changes direction. We'll get to acceleration next. In order for your velocity to become negative, your displacement must become negative, okay? You've actually got to turn around. You've got to change direction. Very, very, very important. Okay, I think time, that's a good place for a quick break. And then when we come back, I actually have a question to do with our viewers, but I think they need to just mull over some stuff quickly.
And then get their brains back into
speed and velocity.
All right. On that note, the mindset is make sure you do not disappear. Do not disappear. I repeat. Make sure that you get on the page, chat to us. Let me know what you guys are thinking. If you're lost, if you need help, post. Even if you're just enjoying the show, just say, hey guys, I'm enjoying the show. But on that note, we'll see you after this break.